Hi boys and girls, how are my scientists doing today? So before we delve any further into this problem, I want to make sure that we can take what we've learned so far and not just say it real quick, but that we can talk like a scientist, because that's what we want to do, right? We want to sound intellectual and smart and so scientific. So let's take our new key concept of when light shines on a surface, the surface gets warmer. And let's think about how a scientist would explain things that are happening. Let's look at some pictures. So here's our first picture. We have a street, and you can see that half of the street's in the shade and half of the street is in the sun. So which picture would show the warmer part of the street, the arrow pointing to the warmer part of the street? Were you thinking like me, boys and girls? Were you thinking it must be this picture because it's pointing to the sunny side of the street? So looking at that first picture, you just want to say, well, that place would be warmer. That doesn't sound like a scientist. A scientist needs to think about how they're going to speak, and they're going to use that cause and effect that we've been talking about. We've done this with living things. We did this when we were studying force and motion, right? We talked about how the marble moved because a force was exerted on it. So we're going to bring that same language framework into our unit now about weather. So we have to think about how would a scientist say and explain what is happening. So here's the language framework that we're going to use so we can talk like a scientist and explain our thinking. So the surface is blank because sunlight is blank on it. So when we think about the cause and effect, right? So the first picture that we just saw, we were trying to figure out which surface was warmer. So the surface being warmer, the surface is warm. That's the effect, right? That is what has happened. And then remember that nice word we always use to explain why the effect happened, because sunlight is. Now, was sunlight shining on it or not shining on it? It was shining on it, right? That's what made it warmer. So we're going to move that word up there. So the surface is warmer because sunlight is shining on it. Okay, so now we're going to look at our next picture. So here's our next picture. We have a nice beach picture. Which picture shows the arrow pointing to the cooler surface temperature? What do you think? Okay, if you were thinking like me, I was thinking about this picture, right? Because the umbrella is making a nice little shady spot on the sand. Okay, so after looking at that picture, how would you talk like a scientist? How would you describe which area was cooler? Well, hopefully you would say something like this, right? The surface is, there it is, cooler because sunlight is, was it shining or not shining? It was not shining, so we're going to move that one up there. Not shining on it. The surface is cooler because the sunlight is not shining on it. Doesn't that sound much more scientific than just saying it's colder, right? We want to be like a scientist and use that cause and effect to explain our thinking. So I have two more pictures to show you, and I'd like you to either write down or make a video, show it to your teacher, and talk like a scientist to explain either which areas are warmer or which areas are cooler in the pictures, and explain that because. Why are they warmer or cooler? Now look at these pictures. Which picture is showing a surface that would be warm? Were you thinking about the same picture that I was? The desert on the left is going to be warmer. Can you explain like a scientist? How about this picture? Which surface is going to be cooler? I hope you were thinking it was the picture that I circled. That arrow is pointing to a cooler surface temperature. Now, can you talk like a scientist and explain why? So thinking what we now know about talking like a scientist, let's go ahead and let's look at the data for the playground that the principals have been collecting about the temperature. Now, they've been collecting the temperature at night and they've been collecting the surface temperature during the day. So let's check that out. So here is Carver Playground's data, and we have a nighttime temperature where it's purple every single night. Remember, purple on the thermometer means very cold. And then our daytime temperature is warm and hot, orange and yellow. Moving over to Woodland Playground, again at nighttime it's purple every night, very cold, but daytime, goodness, it's hot and very hot with that orange and red that we see on the thermometer. So looking at that data, we can see that the surface temperature is warmer during the day than it is at night. So again, can you talk like a scientist and can you explain why is the playground surface temperature warmer during the day and why is it cooler at night? Talking like a scientist. I know I can't wait for my kids to talk like scientists. I bet your teachers can't wait to hear you talk like scientists. Have a great day, and I will see you soon, scientists, as we talk more and more about this playground problem.